Hi, my name is Anna. Welcome to this journey through the exciting world of supply chain management, specifically focusing on robotics and IoT. Today, we are going to study the chapter, which is IoT in real-time supply chain monitoring. In this chapter, we'll explore what IoT is, how it transforms supply chain management, and how its real-time capabilities create smarter and more efficient supply chains. Introduction to IoT for real-time monitoring. The Internet of Things, IoT, is a network of physical objects embedded with sensors, software, and connectivity, which enables these objects to collect and exchange data in real time. In the context of supply chain management, IoT enhances visibility by connecting previously isolated processes. Through IoT, products, facilities, vehicles, and equipment are continuously monitored, providing real-time data. This not only eliminates the delays in manual data collection, but also facilitates rapid decision-making. By creating digital twin representations of the physical supply chains, IoT provides an accurate reflection of real-world conditions. Benefits of IoT-enabled real-time monitoring. IoT has several benefits, particularly in enhancing visibility across the supply chain. It allows continuous tracking of assets and products, reducing blind spots, and providing precise location data. Additionally, IoT enables a much faster response time to disruptions by sending instant alerts, which help organizations take immediate corrective actions. This leads to more data-driven decisions, improving forecasting, inventory optimization, and resource allocation. IoT also plays a crucial role in risk mitigation by identifying potential issues early on, preventing larger disruptions. The role of IoT sensors in tracking products and goods. IoT sensors are at the heart of real-time monitoring. These sensors capture location and environmental data from assets, whether they're in transit or storage. These devices convert physical events into digital data streams that can be analyzed in real time. In modern supply chains, various types of IoT sensors are used, such as GPS for outdoor positioning, RFID for zone-based tracking, and temperature sensors for cold chains. The integration of multiple sensor types creates comprehensive solutions that meet the specific needs of industries such as pharmaceuticals, fresh food, and high-value electronics. Common IoT sensor types in supply chain. IoT sensors are classified into three broad categories. Location trackers like GPS, BLE, and RFID are used to track assets across various environments. Environmental monitors are designed to track conditions such as temperature, humidity, and moisture levels, critical for products like food and pharmaceuticals. Lastly, operational sensors monitor other factors like weight, volume, and fill levels of containers, ensuring that products are in the right condition at every stage of the supply chain. Collecting real-time data via IoT devices. IoT devices are continuously collecting data at predefined intervals or upon trigger events. This ensures there is a constant flow of operational intelligence. The data collection process is optimized by balancing the frequency of data sampling, precision, and power consumption to ensure sustainability. For example, critical data might be collected more frequently, while less important data might be sampled less often to save on power and bandwidth usage. IoT data collection architecture. IoT data is collected in a multi-layered architecture. The sensor layer consists of the physical IoT devices that capture raw data. This data is then processed at the edge computing layer, where it is aggregated and filtered to ensure only the most relevant data is sent to the next layer. The connectivity layer ensures the processed data is transmitted using communication protocols like LTE or Wi-Fi. Finally, the cloud platform layer stores and analyzes the data, making it accessible to relevant stakeholders. The importance of data connectivity and cloud platforms in IoT Effective data connectivity is essential for IoT systems as it ensures the continuous flow of information across supply chains. Cloud platforms provide the computational power and storage needed to handle large volumes of data, and they allow stakeholders to access information from anywhere. Key challenges in this area include ensuring coverage in remote locations, addressing cross-border data transmission issues, and maintaining interoperability between various network types. Cloud platforms for IoT supply chain management. Cloud platforms like AWS IoT, Microsoft Azure, and IBM Watson provide the necessary infrastructure for handling the massive amounts of data generated by IoT devices. These platforms offer data storage and management services such as time series databases and automatic scaling during peak operations. Analytics and intelligence tools built into these platforms help organizations make sense of the real-time data and make more accurate predictions and decisions. Integrating IoT with supply chain visibility tools. For maximum benefit, IoT systems must be integrated with existing supply chain tools. This enables unified visibility and allows IoT data to be placed into a business context. Key integration points include ERP systems, warehouse management systems, WMS, and transportation management systems, TMS. Integration provides businesses with a cohesive view of their operations, making it easier to track assets and manage workflows. The supply chain control tower approach. The control tower model consolidates all IoT data and integrates it with business systems to create a central hub for supply chain operations. This approach offers multi-tier visibility, event management, and intelligent response systems. With real-time alerts and AI-powered recommendations, businesses can quickly identify disruptions and take corrective actions, ensuring smoother operations and better decision-making. The impact of real-time monitoring on operational efficiency. By adopting IoT-enabled real-time monitoring, businesses can shift from a reactive to a proactive approach in supply chain management. This allows for the identification and elimination of inefficiencies, reduction of waste, and optimization of resource utilization. Organizations can expect reductions in product loss, excess safety stock, and transportation costs, leading to significant improvements in overall operational efficiency. Case studies of IoT in supply chain tracking. Several leading companies have successfully implemented IoT in their supply chains. For instance, GlaxoSmithKline reduced temperature excursions by 97% using IoT sensors in their cold chain, leading to enhanced regulatory compliance. BMW Manufacturing used RFID and GPS tracking to optimize their supply chain, resulting in a 23% reduction in parts inventory and improved production efficiency. These examples demonstrate the transformative potential of IoT in supply chain management. Future trends in IoT-enabled real-time supply chain management. Looking ahead, several emerging trends are set to enhance IoT capabilities in supply chain management. These include 5G connectivity, which will provide ultra-low latency for more precise tracking, autonomous systems that can self-correct based on IoT data, and digital twins, which create virtual replicas of entire supply networks for scenario planning. Despite these advancements, challenges like standardization, data privacy concerns, and system integration will need to be addressed.